Hello, I am Philippe Guéchet from the Engineering Knowledge Competence Center, and
Sir, I have a message from the top management for you. The first part of your video about how water affects bearing life is not acceptable. Your behavior doesn't represent SKF engineers well. At SKF, engineers are expected to be professional and serious. Also, your choice of clothing, a denim jacket, is inappropriate. Please wear a tie so your appearance matches the seriousness of your role. We hope that you have understood the message.
hello, I am Philippe Guéchet from the Engineering Knowledge Competence Center, and this video is about the water content in the oil and the influence of its life. It's the second part. Today we're going to talk about why we should remove the water, how we can remove it, and what is the maximum water content that is recommended. Remember, free water, emulsified water, and emulsified water goes up to here. On this part there are very fine droplets, bigger droplets and even bigger droplets. Removing the free water is quite easy. For the droplets which are in the white part, just with centrifugation, for example, we are able to remove, and also the droplets that are in this part. But for the droplets that are here, it's more difficult, and all the part here where there's dissolved water, well, you need some vacuum separators, where I will talk about it. If
Ladies, gentlemen, ordinary
go
mortals
on.
and happy taxpayers, I am the avatar of Philippe Guéchet. I am a serious and professional senior mechanical cup of tea, please, mechanical engineer expert. The title is a bit long, and let's forget the protocol between us. Just call me master.
You forgot humble in your title.
Thank you. I will add humble in my title. I am smarter and more serious than the real Philippe Guéchet. I am an artificial intelligence able to create educative and marvelous videos for SKF ignorant applications engineers. I can speak Italian. Sono un'intelligenza artificiale in grado di creare video educativi e meravigliosi. I can speak German. Ich bin eine künstliche Intelligenz, die lehrreiche und großartige Videos erstellen kann. I can speak Chinese. Wo shi yi genen gu ji so ju yu jiao yu yi yi he jinkai ying pian de ren gong chi hui, and plenty of other languages. I never do errors, and I'm totally reliable. I can give more information about water content in oil and in a more educative way than an ordinary mortal can.
Really, show it.
Thank you for agreeing.
I didn't agree.
Like Philippe clumsily showed in the previous video, free water is more dangerous for the rolling bearings than dissolved water. Such diagram on the right that lets you believe that the Cantley equation is valid also for free and emulsified water is just grass transformed by a bull. This diagram has not been created by a serious engineer wearing a tie, but certainly created by a serious professional marketing and communication expert. Unfortunately, this misleading diagram is found on the net. Free water can create corrosion, especially at standstill. This picture shows standstill corrosion, and this picture shows a spall created by a standstill corrosion. Even if you do not see any corrosion, the spall is a typical spall created by a damage that happened during standstill. The spall then propagated in the rolling direction. Based on the application, the measured water content in the oil and some mayonnaise found in W33 holes, it can be stated that the most probable cause is standstill corrosion. Corrosion points creates weak points in the steel and reduces bearing fatigue life. I can also talk about the material strength of a bearing that can be negatively influenced by water content that generate hydrogen and creating white etching cracks. But I do not want to go into simple and obvious explanations that would be still too complex for the audience. Many think that water in the oil would decrease the lubricant film thickness. This is true, but only over a certain water content. Below a certain water content, it was noticed little or no influence on the film thickness. Of course, above a certain water content loose of lubricity, higher friction and adhesive wear will appear. Water in the oil brings a loss of oil additives. This is especially true with free water. Many oil additives are polar, meaning there is a small positive and negative electrical charge on different part of the molecule. As water is also polar, water and additives are attracted towards each other. The overall result is that many oil additives become closely associated with water molecules. If free water is present, these additives tend to leave the oil and dissolve in the free water. When water is drained out the lubricating system, the additives are also. In other cases, polar interaction with water molecules causes the additives to precipitate out of the solution, creating sludge. Water accelerates the oil aging. In the table on the right is indicated the variation of the TAN, total acid number, of the oil. The TAN number variation is a good indicator of the oil aging. One rule of thumb is that oil should be changed if the TAN number variation is bigger than 2. In some applications it could be only 1. The table is from a laboratory test following ASTM D943 oxidation test procedure using turbine oil in pure oxygen. It can be seen that water alone increases the oil aging rate, but the aging rate isn't comparable as soon as water is with iron, or even worse with copper. Remember that bearings, shafts and housings materials have iron and that some bearings have brass cage that is a mixture of zinc and copper. I will not talk about microbial growth due to free water and cavitation, less to do with rolling bearings, and anyway I present what I want to present. As you can understand, water and oil should be avoided, but it is impossible to have no water. There will always be a certain amount of water in the oil. The main question is what the maximum amount of water is acceptable. The answer is that all free water should be removed, and the amount of dissolved water will depend on the application and the oil characteristics. First, let's see what the maximum water content for an application is. You can often read in SKF documents that the maximum water content is 200 ppm. Sometimes it is stated that 500 ppm water is acceptable in operation only. This is in fact based on investigations done by the pulp and paper segment some 35-40 years ago by serious and professional engineers experts. They were wearing ties. Have a look at this photo of application engineers in 1992 at an application technology course. They all wear a tie. They were all serious and professional.
There's one in the back that doesn't wear a tie. He has a denim jacket.
They all wear a tie.
No, not at all.
Show me the one that doesn't wear a tie.
You removed him. Come on.
No, I didn't remove him.
Yes, you did.
No, I didn't. I do not answer with patent insincerity. I am a serious and professional senior mechanical, a cup of tea, please mechanical engineer, humble expert. So stop reacting like a child and let's move on. Investigations were done in Swedish paper mills on paper machines. Water content was measured and customer would give bearing failure history. There is a certain amount of bearing failure considered as normal or accepted based on calculated rating life. Due to the SKF 5S, we do not know the details of the investigations, but we can trust the engineers that did the investigations since they were wearing a tie. Removing the cases that were clearly standstill corrosion, the result can be seen in this diagram. During operation, only above 500 ppm water content will have a negative impact. It is not clear how the relative life below 100 ppm was determined, since most labs in paper mills couldn't measure with precision water contents below 200 ppm, but we can trust the engineers that did the investigations since they were wearing a tie. The 200 ppm recommendation comes from the fact that machine has maintenance stop. The diagram shows the water saturation curve for a typical ISO VG 220 mineral oil formulated for paper machine application. Below the blue line, the water is dissolved. Above the blue line, part of the water content becomes free water. The lubrication method is circulating oil. Oil inlet temperature is depending on the application between 40 and 60 degrees Celsius, and bearing temperature is above 60 degrees Celsius. So for example, water content of 500 ppm is dissolved water when the oil is in the bearing. But during machine stop, when the bearing temperature decreases, part of the 500 ppm becomes free water and could create standstill corrosion. With such oil, formulated for paper machines, so with good anti-corrosion additives, a maximum 200 ppm water content recommended, machine in operation and machine at standstill should avoid lower bearing service life than expected. Your application that is not a paper machine might need different maximum water content recommendations. You need to have the water saturation curve of the oil and bearing failure history to build your own recommendations. Most important is to avoid free water and then investigate what is the maximum dissolved water content acceptable. Some could think that the choice of an oil able to absorb a large quantity of water is a good idea. Like, for example, some polyacrylene glycol synthetic oil that can absorb up to 10,000 ppm water. But that choice would mean more complex and costly water extractor systems, as dissolved water is more difficult to remove. It isn't a good choice for paper machine bearings lubricated with circulating oil, but can be a good choice for bearing lubricated by oil bath with little maintenance, such as gearboxes located outside with high risk of internal condensation due to ambient temperature variations. The choice of water extractor system depends on the maximum dissolved water accepted in your application, the saturation curve of the oil, and the amount of water per unit of time entering the system. But that is another story for another video. As you can see, I have done a wonderful educative video and I do not discuss salary increase. You can now fire the real Philippe Gachet. Anyway, SKF doesn't lose anything, he is obsolete. What do you have in your hands?
Nothing.
Nothing?
Nothing.
Sure?
Sure.
We apologise for the unexpected interruption of the video due to the extreme violence against an avatar. Let's meet Officer Valeria in charge of the investigations on site. Valeria, can you tell us more about what happened?
Yes, of course. The avatar was shot and finished off with a rifle butt. The suspect, an ordinary mortal, has been arrested. The reasons for his actions are unknown at this stage of the investigation. However, we suspect that his has lost his temper after understanding that he would be replaced by a digital artificial intelligence.